In today's video, we're going to look at section 10.3, Verify Trigonometric Identities. There are three learning targets in this section. Learning target 10.3a is I can find the trigonometric values using the fundamental trigonometric functions. Learning target 10.3b is I can simplify trigonometric expressions. And learning target 10.3c is I can verify trigonometric identities. To start out with, we need to look at some of the identities that we have. Now, all these identities that we're going to go through are found on the unit circle sheet that I gave you in the last chapter. So you don't have to memorize these. You will be allowed to use them on any test or quiz. But know that they exist because we will be using them quite a bit over the next couple sections. So the first set of identities is called the reciprocal identities, and that's just the ones that show you which trig function goes with which reciprocal function. So like the sine goes with the cosecant because the sine is the same thing as 1 over the cosecant. The cosecant then is the same thing as 1 over the sine. And then secant and cosine go together. So secant is the same thing as 1 over cosine, and then the cosine of u is the same thing as 1 over the secant of u. And then your tangent and your cotangent go together. So the tangent of u is equal to 1 over the cotangent of u, and the cotangent of u is equal to 1 over the tangent of u. The next set of identities is called the tangent and cotangent identities. The reciprocal identities were just ones that you kind of knew we've used before when finding the 6 trig values. We knew that we had to do the reciprocal of, say, the sine in order to get the cosecant. So we've used those reciprocal identities before. So now the tangent and the cotangent we haven't really used before, but we will use them quite a bit as we get more and more into simplifying and solving trigonometric expressions. So this tangent is always equal to the sine divided by the cosine, and the cotangent is always equal to the cosine divided by the sine. We have a couple more sets here. The Pythagorean identities, again, another set of identities that we're going to use quite a bit. So they're ones that you definitely need to make sure you know. The main one is that top one there, the sine squared of u plus the cosine squared of u will always equal 1. Now we do, like I said, we use that one quite a bit. That's the one we use a lot. So by the time we get done with this chapter, you'll really know that sine squared plus cosine squared is equal to 1. The other Pythagorean identities, which we still use quite a bit, but not quite as much as the first one, is 1 plus the tangent squared equals the secant squared, and 1 plus the cotangent squared equals the cosecant squared. The cofunction identities is how we relate one function to another using that pi over 2, or in terms of degrees, 90 degrees. But these here are all written in radians, but know that you can convert them to degrees by changing all the pi over 2's to 90 degrees. And then as you can see here, there are 6 different identities. The first one being the sine of pi over 2 minus u is equal to the cosine of u. And then going across the top, cosine of pi over 2 minus u is equal to the sine of u. Cosecant of pi over 2 minus u is equal to the secant of u. Tangent of pi over 2 minus u is equal to the cotangent of u. And then the last set, secant of pi over 2 minus u is equal to the cosecant of u. And the cotangent of pi over 2 minus u is equal to the tangent of u. So those are our cofunction identities. They just kind of show some relationship between the angle that you're given and the 90 degrees. And it all kind of relates back to kind of your right triangles. The last set of identities we're looking at before we do some problems is the negative angle identities, saying that if you're doing the sine, the cosine, the tangent of a negative angle, what that is actually equal to. So if you notice, just by looking at them, all of them end up being the opposite of the trig function except for the cosine and the secant. So the cosine, so this one right here, and the secant are the only two of the 6 that will always equal the same thing. So if I have the cosine of negative 30, that is the same thing as a cosine of 30. But like the sine would be, if I was doing the sine of negative 30, that's actually equal to the negative sine of 30. So cosine and secant stay the same, they stay that positive, whereas the sine, the cosecant, the tangent and the cotangent all have to be the opposite of the original trig function. Now let's look at an example of the first learning target, which uses some of these identities in order to find trig or different trig values. So in this case, they say, given that the tangent of theta is 5/12 and that theta is between pi and 3 pi over 2, find the values of the other 5 trigonometric functions of theta. Okay, so they give us tangent, we have to find the rest. So what I'm going to do is just over here off to the side, I'm just going to make a list so I know which ones I have to find still. So sine, cosine, tangent, they did give us, so I'm just going to go ahead and put that in here of the 5/12. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So by knowing that the tangent is 5/12, it makes it very easy for us to find the cotangent, which is just the reciprocal of that, so it's 12/5. So I've got 2 of the 6 that I need. So now I need to find the other 4. So to do that, they want us to use these trigonometric function values. So they want us to use those identities that we just talked about. So one of the identities, because I know that I have tangent, what I need to do is find one of those identities that relates a tangent to some other trig value. So of those identities that were given, we already used the reciprocal because the tangent goes with the cotangent. One of the other ones is that Pythagorean identity that says 1 plus the tangent squared of theta has to equal the secant squared of theta. And really there's no right or wrong way to do this. If you found a different trig identity to use, then feel free to go ahead and use that one. This is just one that, comes to mind for me. Now that I know that the tangent is 5/12, I could take and plug that in. So I have 1 plus. Now remember, tangent squared of theta, so off the side here, tangent with a little squared up there means the same thing as the whole quantity of tangent of theta squared. So this is telling me that whatever tangent is, I'm going to square it. So I know that tangent is 5/12, so I'm going to square that, and that's going to equal my secant squared of theta. So I'm going to go ahead and simplify this. So I get 1 plus 25 over 144 equals the secant squared of theta. So when I add those two together, I get 169 over 144 equals the secant squared of theta, and then I take the square root of both sides. Which gives me then 13 over 12 equals the secant of theta. Now this could be, because I took the square root, could be either positive or negative. So to determine whether it's positive or negative, I look at the fact that they told us that theta was between pi and 3 pi over 2, meaning that we're in the third quadrant. So to determine whether secant is positive or negative, I do the all students take calc. So in the third quadrant, only the tangent is positive, meaning that the reciprocal function would also be positive. So both tangent and cotangent are positive in the third quadrant, meaning that my secant has to be negative. So I'm just going to go ahead now and add that over to my list. So secant comes out to be, so find secant. Secant comes out to be a negative 13/12. Now, because I know secant, I can do the reciprocal function of that. So cosine then is the reciprocal of that, so negative 12/13. And then the last thing I need to do is find sine. So I need to try to relate one of my trig values that I already know into my sign. So the one that comes into my head right away that I think of is always that Pythagorean identity. And like I said, it's the one that you're going to use quite a bit. So make sure you get real familiar with it. And it says that the sine squared of theta plus the cosine squared of theta has to equal 1. Well, I'm looking for the sine. Cosine we just found, so I'm going to leave the sine. So sine squared of theta plus the cosine, which we just came to find out that it's 12/13, and it's cosine squared, so that means that quantity is squared, and it equals 1. So now just to simplify, I get that the sine squared of theta equals, oops, I don't know what happens there, equals 25 over 169. So I took and squared the negative 12/13, giving me 144 over 169. And then, because it was equal to 1, I now subtract that over, so it's 1 minus that quantity, leaving me with a 25 over 169. Now we go ahead, just like before, and take the square root. So I get the sine of theta is equal to, and now remember I can just go ahead and do the square root of top and bottom. So square root of 25 is 5, square root of 169 is 13. Then again, it is a positive negative, so it's either plus or minus. I look at the all students take calc again, and because it is in the third quadrant, tangent is the only, tangent, cotangent would be the only ones that are positive. Since it is a sine, sine needs to be negative. So when I write that up here, I get a negative 5/13. And then I do the cosecant, so I flip that over, so negative 13/5. And there are my 6 trigonometric functions. Now keep in mind, they didn't ask for the tangent, but I like to go ahead and just put it in that list anyways, because then it helps me remember the reciprocal, that the cotangent is the reciprocal. Okay, so let's now look at one more example of using our trig identities to solve for our trigonometric functions. So this is this is example 2, learning target 10.3a. Find the values of the other trigonometric functions of theta when sine of theta is equal to negative 3/7 and theta is going to be between pi and 3 pi over 2. The first thing we want to do, like we did on the last one, is try to find an identity that uses sine and some other trig value. So in this case, I'm going to use that most common one of sine squared plus cosine squared has to equal 1. In this case, sine is a negative 3/7. So remember, it's the quantity of sine squared. So in this case, it's going to be negative 3/7 squared plus still that cosine squared of theta equals 1. So negative 3/7 squared is going to be 9/49 plus the cosine squared of theta has to equal 1. So now I'm going to subtract over that 9/49 and get that the cosine squared of theta is equal to 40 over 49. The last thing I need to do is go ahead and take the square root of both sides. I'm going to take the square root here and the square root here. And when I do that, on the left side I end up with just a cosine of theta. On the right, I get plus or minus, because anytime you take a square root, you've got to remember the plus or minus. The square root of 40 over the square root of 49, which happens to just be 7. But we know that the square root of 40 will break down further. 4 goes into it. The square root of that is actually 2. And after I divide that initial thing by 4, I get 10. So it's 2 square roots of 10 over 7. And the last thing I need to do is check my quadrant. So all students take calc. We are in the third quadrant. In this case, again, tangent and cotangent are always going to be positive. Everything else is negative, meaning that the cosine actually needed the negative value, not the positive value. So there's my cosine. Sine was given, so now I need to figure out tangent. and then I can just do the reciprocal identities. So tangent, remember from earlier, is sine divided by cosine, which I very nicely already know because they gave a sine. I just found cosine. So the tangent is going to equal the sine, which they gave us to be negative 3/7. And then we're going to divide that by, and instead of writing it over, I'm just going to hit divide by negative 2 square roots of 10 over 7. Now remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So I leave, so negative 3/7 change, so change divide to times, and then flip the second one, so 7 over negative 2 square roots of 10. So now I want to cancel anything possible. So I cancel those 7s, leaving me then, because that's all I can cancel, leaving me with negative 3 over, and actually that negative could go away because there's a negative on the bottom. So I end up with just 3 over 2 square roots of 10. But in math, we can't leave a radical in the bottom, so I multiply both the top and the bottom by the square root of 10, giving me 3 square roots of 10 over 2 times 10, so 20. And there's my tangent. But it did ask for all the values of the other trigonometric functions, so now that I know sine, cosine, and tangent, I can do their reciprocals. So sine was given at negative 3/7. Cosine we found to be negative 2 square roots of 10 over 7. And the tangent we just found to be 3 square roots of 10 over 2. Over 20, sorry. So now I just do the reciprocal identity. So of sine, that would be our cosecant. So that's a negative 7/3. For cosine, it's going to be secant. And do the reciprocal, so 7 over 2 square roots of 10. Again, we can't have that square root in the denominator, so I'm going to go ahead and multiply top and bottom by it. And I get 7 square roots of 10 over 2 times 10, or 20. And then the last one I need, and I'm just going to squeeze it over here, is the cotangent. Cotangent of theta is equal to the reciprocal of the tangent. So 20 over 3 square roots of 10. Can't leave that square root in the bottom, so I multiply top and bottom by the square root of 10. So I get 20 square roots of 10 over 3 times 10, so 30. And then notice that I can reduce that a little. 10 goes into both my numbers. So I get 2 square roots of 10 over 3. And it is in, that's cotangent, it is in the third quadrant. So cotangent is positive. Tangent is also positive, just double checking my values. And then the other 4 are negative, which I do have. So I've got sine as negative 3/7. Cosecant is a negative 7/3. Cosine is negative 2 square roots of 10 over 7. Secant is negative 7 square roots of 10 over 20. And then tangent is 3 square roots of 10 over 20. And cotangent is 2 square roots of 10 over 3. And those are my 6 trigonometric values using the identities to find these values.